All right, everybody, we are going to be working on Unit 3 some more today, and we're going into Part D, which is enums and switch. And this is like the last required section in this unit, by the way. This is an important one. We just came out of the structures playground where we learned how a structure operates. Now we're going to look at enums, which is somewhat similar. And then we're also going to look at switch statements and hopefully get through the playground today. I am opening up the playground. Of course, it comes up on screen number 2. And I want to make sure I have the student version here. I do, which is good. The teacher version is down there. All right, so let's go through this and see what it has to say. All right, so reading through, it says, you're often given a lot of choices to make in life. In many cases, you must pick one of a set of options. And picking nothing isn't a choice, right? So, for example, a restaurant might offer a limited lunch menu with 3 options for entrees: pasta, a burger, or soup. The system works well. The restaurant's manager knows exactly which ingredients need to be on hand every day for lunch, so they can order supplies well ahead of time. The kitchen can prepare and serve each meal quickly and efficiently, and no time is wasted understanding or taking down special orders. You just pick one of the 3 and you're all done. As a programmer, you can benefit from applying these same kind of controlled choices in your program. And if you think about software that you use, that's often the case, right? You don't usually get in-between choices, right? You get like this one or that one or that one, very commonly. So consider the lunch options from the previous page. It says if you're writing a function for the restaurant's online order form, you might do this. All right, so we have this function where people will enter their choice, and then it'll return a string. So if the choice is pasta, we'll return, and of course, I think it's a picture of spaghetti with sauce and a fork twirling it or something. I think that's what the emoji is. I guess I could zoom in. Otherwise, the choice is burger. We get a burger icon, and otherwise, we get the other one, which was, I don't even remember what the other option was, soup. Okay, so pasta, burger, or soup. So apparently that's a bowl of soup, right? And then, of course, to run the function, we would call it and we would feed in our option. And of course, the return is the bowl of pasta. All right, so the other thing they want us to do here is to kind of experiment a little bit. And this is a pretty simple thing to do, so you guys may as well. So you can cook lunch, and then your choice might be a burger. And then hopefully that pulls back a burger. And then you may as well try the other option, which is cook lunch. And well, the other one's an else, right? Could I just do this? Would I get soup?
Maybe no, you
Oh,
have to have
right. So I do need to,
because you get to call the object.
yeah, you do have to, exactly. So, but could I feed in a choice and make it empty? Yes. So you still have to, whatever data type it's expecting to receive, you can't just let it hang. You can make that empty, but so for example, I could put soup here, or, and really the last one doesn't check for the word soup, so it doesn't really matter. I mean, I could put in, whatever, and I'll get soup. Right, and that's just the way that the logic is written, right? All right, now they're pointing out that this has some problems with it, right? If you ask for anything other than exactly pasta or burger, including upper lowercase, you get soup. So I could ask for pasta with a capital P, right? And I would get a soup. All right. There's nothing telling you what you can ask for if you can't see the body of the function. All you know is that it takes a string, but it doesn't tell you any of the strings it might expect, right? So you can see the limitation there. And what they're trying to point out is there's a better way to deal with this. Okay, so here's the suggestion, right? In Swift, you can use what we call an enumeration or an enum to represent a group of related choices. Each choice is called a case. So you can define your own enumeration types just as you define your own structs. So take a look at the syntax on this. So we have this thing that says enum, lunch choice. Also look at the convention here of an uppercase first letter. That's pretty important too, right? So there's uppercase first letter. And then we have the three different possible cases listed: pasta, burger, or soup. All right. So this really does create a brand new type, as we call it in Swift, called lunch choice. And it can be any one of the three that's listed there. Yeah, we do call it an enum, which I've been already calling it. And, it, for whatever reason, they came up with this thought that it starts with a capital letter because it is a type, the same way a string is a type. Right. Now, the stuff that's inside of there, all the cases, those all start with lowercase letters. That's kind of the convention. And they also suggest that the name of the enum should be singular, as in lunch choice, not lunch choices. Because ultimately, you're only going to pick one of them. You can't pick all three, right? So make it singular so it makes sense to you, right? So if you want to actually create an instance of the type, I would just simply say lunch choice and look at the syntax on how beautifully simple this is, dot burger. So in essence, because burger is already built in as a case, a property, and we're not like feeding it in or setting a value to it, we're just selecting it. So lunch choice dot burger. Okay, makes sense. Right, really quickly. I mean, both in how it reads and how it delivers the data. So that would then get stored here. Right. Now, what happens if I get a situation like this where I throw in something that is not on the list? Okay, well, sorry, there's no fish today, right? It's not one of the options, so you can't call it. Okay, so yeah, that's a little bit of a problem, right? But what's kind of fascinating and often how we use these enums is to feed structures within our program, for example, like a drop-down list where things are pre-populated and people have to pick one item, right? They can just pick from the list. And then that's really kind of how this operates. If you keep that in your head as you're kind of doing it, it makes a whole lot of sense, right? And to me, that's how I kind of wrap my head around it. All right. It says, experiment. You and your friends are going out for lunch, create constants for each person and assign them different cases in the enum. And notice how auto completion shows you the possible options. Okay. So for example, let Jomar's choice equal, what do you want for lunch there, Jomar?
I'll take the burger.
All right. What about you, Jonathan?
I will do the soup.
All right. Yesterday I had soup, so today I'll have a burger. Pretty simple, right? I mean, but the case in point is it's really not hard to execute this code once you have your enumerations or your enums set up. All right, let's learn a little bit more now. It says Swift can save you some typing when it expects a certain type of enum. So here's the lunch choice enum from the previous page. And now notice the rewrite on this. And I think this is kind of fascinating, right? That basically, because we just have three cases, right? Yeah, we can put them in a list separated by commas. That works too. So I don't have to like spell out each one. All right. And so we made choices here. Let the choice equal a burger. this variable has a type annotation. So notice I can create a variable called choice. This is really bizarre, by the way. It's a bizarre language feature. So we're going to create this variable called choice. And of what type is it? The enumeration called lunch choice. It's of type lunch choice. So what's my choice? That burger. Now, what's fascinating about this is what they're telling you. The type format's built into the variable. And now I can just simply declare my choice by just saying choice dot burger. And you know what? Because choice is a variable, I can also say choice equals dot soup, right? Or choice equals dot pasta. And those are all perfectly valid. Isn't that really an interesting syntax? Very interesting syntax. Very useful, by the way, because that whole type is stored here already. And then all we're really doing here is adding a property, and it allows us to do it. It's a really interesting approach. So it is kind of a weird thing when you learn how to use these sort of mechanisms. Like, okay, what's the use case scenario for something like this? And it says, whenever you have a restricted group of related values in your code, it might be good to think about using an enum, right? So like, for example, you might have a choice. I'm attending class today or I'm not. There's no in between, right? You can't like half attend class. You're either gone or you're not, right? I guess you can leave halfway through, right? One way or the other, you're either gone or you're not. If there are no restrictions on the value or you have a large number of possible value, enums probably are not a good fit. Catch that, right? So if you walk into Woodman's, what do you want to eat, right? Well, oh my God, anything, right? If you walk into this restaurant we were talking about, they've only got 3 things in the menu. Well, it's soup, pasta, or burger. Sorry, that's it. It says, or if you have a large number of possible values, so you have a finite list, but it might be 500 items. Maybe that's not a good fit. And I think what they're trying to tell you is that the structure really isn't built for that. Right? So it says, imagine you're writing an app, a fun little sports game. You're using a struct to represent each player on the field. Each player has the following properties: name, skill level, team, and position. Pretty common, right, for somebody on a sports team. Name, obviously a string. Would you use an enum here? Well, no, right? Too many possibilities. I mean, names can be almost infinite, right? Skill level would be an int. And since the game uses a point style system as the user gains skills, would that be a good one to use as an enum? Okay. All right. Maybe not, right? Because, for example, like if you're thinking like baseball players, like in the batting average is a really good example. That can vary throughout a season or throughout their career, and you know what? That's going to change, right? And it's not like precise values. You're not like batting 1,000 or batting 300. You know what I mean? So it could be 301 today, and tomorrow it's 302. You know, right, it's not a good one. Team would be a good enum because there are only 2 teams on the field, red and blue, for example. Or if like, let's say your football teams, right? There's only so many football teams. That might work. Position could also be an enum. So if it's, depending on the sport you're playing, and I think quarterback, seeker, and pitcher, if I'm not mistaken, is that all those all rugby terms or I'm trying to think of what's the other British sport? Cricket? I forget, like, because they have like really weird names. I think those are all names for people on a rugby team. I'm speculating, right? It says here, defined enums to represent the team and position options. So that's kind of already given to us, right? But so this is pretty easy to do. You can use the list up here or the examples from the previous page, if you want to take a really quick look, go back on how to do that. So you're okay. Now I'm all locked up, waiting for my little spinning wheel. That's really exciting for a video for sure. So I'm pausing. All right, so I had a little lock up there, so I had to reopen this playground and restart Xcode. But my point was to go back one screen here to look at the previous page, and hopefully it doesn't lock up again. Okay, this time we're okay. But all I was really trying to do here, folks. Okay, so now it's locked up again. Something on that page. All right, I think I can build an enum without looking, but I wanted to look on purpose, right? Because I wanted to kind of refresh what the structure of an enum should look like. So let's once again, Command Option Escape here. I'm going to do the force quit on the video this time. So if you get locked up, Command Option Escape, you get the force quit panel. I am closing Xcode. And by the way, I'm not going to go back a page this time. Because every time I do that, so I can go back to page, but when I try to scroll up is when it crashes. Very, very weird. Not really sure why. All right, so let's just try to do this then. So I'm going to go ahead and use the keyword enum. And then we were told that we could use team and position, right? So I'm just going to create team. And notice once again here, singular, right? And then what case do we have for team? Well, it's going to be red or blue, right? So I can just red, comma, blue, and I'm done. That's it. That's all there is to it. You can see how simple that is. Then they also said you should do this for position. So I'm going to say position, curlies, and the positions that we have available.
Should these be capitalized, the enums?
You know, that's an excellent point, sir. Yes, because they're a type. Correct. Yeah, you know what? I was going to make a point about that, but I forgot to do it. So thank you for mentioning it. The other point that they made was keeping it singular, because even if there's multiple choices, it reads better because, you know, which position are you playing? You're not playing a bunch of positions, or which teams are you on? No, that doesn't make sense. Team makes sense. So for position, we were given the case of, quarterback, seeker, and pitcher. And I could have spelled each one out separately, right? Real interestingly, you know, for those of you studying other languages, and you know, and Jonathan, with you, I'm thinking about Java, right? You don't usually learn about enums in Java until you get to pretty advanced levels, but this also exists in Java for the very same reason. And the syntax is slightly different, but basically the same type of approach, if you're wondering. All right. So let's do a little comparison then. Let's make my screen ever so slightly bigger. So here's the lunch choice we saw before, pasta, burger, soup, right? You can compare values using the equivalency marker, the double equal sign, just like you can with strings and ints. So I can compare types this way. So for example, here's my enum structure, pasta, burger, soup, and my lunch is a burger. Your lunch is a burger. Now I can run if statements and compare the types here directly. So even though they're not like ints or strings or doubles or anything like that, right? Because they're of a type and you will have a consistent value, I can check those values against each other and perform programming logic. So if my lunch is the same as your lunch, hey, we're having the same lunch. Otherwise, hey, can I try, you know, can I have a bite of your burger? Is really what it should say. But yeah, I mean, so what they're telling you is it truly is treated as a type, kind of like a data type, where you can actually do comparisons based upon it. And, think about the enumeration. We're really selecting from one of a limited number of options. So it makes sense that it would work, right? So what they're saying here now is change my lunch to something else. So I could change it to like soup, for example. And then notice how the else is now catching. Can I try your lunch? All right, let's move forward. All right, so now we have another reiteration of the same enum. So we have pasta, burger, soup again. And, we can also, and the point of this is basically that we can use enum values as parameters for functions. So if you look at this function defined on line 12 here, it says the function cook lunch. We have an internal variable called choice, right? Like, we've seen before, right? We saw this if else statement before. What are we feeding into it? Of type lunch choice, right? Now think about what the enum is. It's going to be pasta, burger, soup, right? One of those three. And, notice also the underscore here, which means we can feed it in any fashion, right? And then the return is going to be a string. So we're saying if choice dot pasta. So you see like how we're using that property like we did before, because choice is, we're feeding in of type lunch choice. The same thing happens here is as we're feeding that information in, it's of that data type. We can extract the property. So the dot pasta dot burger and whatever dot soup, if it was there, are properties that we're looking for from that type that then can be used to process logic. So once again, we can use the objects that we're creating to process logic. And so if you look here, if I call that function cook lunch and then throw it at a burger, well, I get a burger. All right. So let's try calling it a few more times. So we'll say cook lunch. And this time we'll put in soup. There's my soup. Even though that one doesn't have, a lookup for that property, it still works because it catches the else, right? And then if I cook lunch and I say dot pasta, bring that, and let's go ahead and get a burger because, I was kind of feeling like one today and I just didn't get one. So I had a turkey sandwich instead. There you go. I probably saved myself like $15 in the process, right? For the cost of a good burger these days, right? There you go. Right. So here it says using the lunch choice enum instead of a string solves the issue that this function had when it took a string value. There was no way to know what was on the menu. So like you go back to this, right? Now, knowing what's on the menu makes it a lot easier to make a choice is kind of the whole point. So when calling a function, you have to pass in a lunch choice. Auto completion will tell you exactly what the options are. Now, as coders, that's helpful for us, right? But that also kind of extends into the user interface. And this is what I was talking about before, where if you use an enum to drive the value for a field, it might give the user the options right up front as to what the possible values are, right? So rather than, it's like walking into McDonald's and you look up on the menu and they have nothing on the board, right? As opposed to like, oh, you can get a Big Mac, a fish sandwich, or fries, you know what your choices are, so you choose from the options that are available. All right. They are pointing out, though, that there's a little problem with an if statement, right? All right, so it says an if statement is useful for checking a single condition, but when if statements are used to check multiple conditions using else if, they can start to get unwieldy, right? Now, here we only have one else if, whatever. That's not really out of control, but I have created programs where it's been if, else if, else if, else if, like it gets crazy how deep it goes. And what they're pointing out is that the code ends up being visually noisy, right? With a lot of repetitions, and it doesn't really necessarily add anything by doing the repetition. right? The left-hand side of the image below shows an if statement with an enum, and you can see that a lot of text is repeated, and the enum cases get lost in the rest of the code. Right? It's really, really easy to kind of overlook stuff. The right-hand side of the image highlights another problem with the if statement. That is, the last choice isn't really anything else, it's soup. If you're reading this code without knowing the last case in the enum, you'd have to guess what that would be, right? So this if statement doesn't help drive good code because we're not really truly getting the option of the soup. I mean, I could write it so it was like else if soup, right? That's not what our code was, by the way. Ours just was else. But even with an else if, right? It gives you that situation. If you're reading this code without knowing the last case in the enum, you'd have to guess. Rewriting the function to use each specific case doesn't help the situation much. So here's they're saying, so if I add the else if for soup, it really doesn't necessarily solve the problem. Here's the other issue. If you do else if, right, then you have no else. You kind of need to put in a return statement here. And if I'm not mistaken, I think if I uncheck this, I think Swift will, yeah. So notice what Swift is doing at the bottom there. They're saying, hey, hold on a second. You got else ifs. You don't have a catch-all else. So you better put a return at the bottom, even if it never gets executed. But in the situation where the choices are pasta, burger, soup, and one of those choices isn't made, you have to have a fallback. Now, I would rather see it in the form of an else, but that return is kind of like an else here, really, right? It will only execute if the other conditions don't stick. All right. It says experiment. Comment out the final return. Oh, we already did that. Uncommented again. Try to change the value past the cook line so the final else statement is called, right? And that's already been done. How would you get an enum value that didn't match anything in the if statement? Well, here's the answer. You can't, right? Simple. Yeah, simple as that. All right, we're going to move on to the next slide here. Now we're going to move on to what is really the kind of the preferred tool to use with enums, right? So now if you guys are learning other languages, right, this is a really natural progression off of the if statement. The switch statement that we're about to learn about is kind of a way of making your if, else if, else if, else if, else if a lot more streamlined and orderly. And, the enum is a great feeder for it. All right. Okay. So we said, we've seen that if statements are a great fit for checking enums. All right. They can still work though, right? It's just a matter of writing the code correctly. They add a lot of visual noise and they can't tell you that you covered all the cases, even though the point of enums is to provide a limited list of cases, right? So that's what they're trying to solve here. What's a better way to choose from different courses of action based on the value of an enum, right? The answer is H switch statement. So we still have the same enum. We set up a choice. Now the switch statement, and look at the syntax of this. Once choice is a value that's set, right? And keep in mind that choice is a complex type, right? So it's that whole enum structure with a selection made. We read that complex structure here. We look at the property to see if there's pasta, burger, or soup, right? And once again, using that dot prefix, which shows that it's a property of that complex object. And no fancy syntax here. It's just case, the thing you're checking, and then a colon. And then it just lists whatever it is. In this case, it's an emoji, right? And notice there's really no else in the mix here. You're only given 3 choices. Now, formally, a switch statement does actually have a fallback, right? But in this, it doesn't have to, right? So the switch statement is a really slick and efficient way to accomplish the same thing. And notice how much cleaner the code is on it. And this is really what I dig about it. And switch statements, by the way, when you are dealing with a limited set of choices, and you're processing those limited set of choices, especially when it gets more and more complex, the switch is an awesome thing. So think about like this scenario, like you guys are filling out an online form, like you're shopping or a questionnaire or something. And then it's like, okay, put in your name and address and city and state, and you get to the state thing. And what do you get for the state thing? You get a drop down box. And there are all the states listed, right? Like maybe 2-letter initials, or maybe the whole name of the state. Maybe they throw in like Puerto Rico and Guam and I don't know, whatever, maybe the Canadian provinces just for good measure. But regardless, that stuff is thrown in there and it's on a list. And typically when you're pulling off of that fixed list of options, then often it's processed with a switch statement on the back end, right? A very, very, very common type of approach. So the switch statement looks very much like the enum declaration above, because they're designed to work together. That's really the kind of the whole point. They kind of were developed at the same time. All right. So the switch statement starts with the keyword switch, followed by the thing you're feeding in, a set of curly brackets, and then you simply enumerate the selections or the properties. And it's really clean and simple code. And you know what, really much easier to work with than the if statements. The if statements have a whole bunch of spots where you might generate an error if you're just basically not careful. Right. What I'd like to do right now, you guys, is let's take a quick little break. I'm going to put us in pause. All right, we're back from our break, and we're going to look at this next page here. And this is kind of an interesting feature here that we're about to look at with switches, which does not happen with if statements. And this is really important. Whenever we use a switch statement, they have this capability within them, and in that they must be what we call exhaustive. So in other words, they must cover every possibility. And so I think this is really kind of a neat, unique feature. So like, for example, if I'm pairing this up with lunch choice, pasta, burger, soup, the switch has to match it. So I have to have the same exact capabilities in both. Right? So let's try what they're suggesting here. It says add another case taco to the enum. So if I come up here and just say, oops, case taco. Says what happens to the switch statement. It took a second, right? But then the compiler kicked in. It says switch must be exhaustive. So it tells you right off the bat when you're setting up a switch and you're matching it up to an enum. And now you can, I think, immediately see the value of this, right? Like, because if you're forgetting one, the compiler tells you. So I can just very simply add that case in here. And you know what? This is totally doable too, because I think there's like a taco emoji somewhere. Probably, I mean, if there's a soup emoji, there's got to be a taco.
There is.
Right? So you can put in your quotes here. And then you guys remember how to do the emoji panel. You just hit that function key. And oh my God, I am searching in the panel now for it. You know what? Actually, I could just probably type taco. Right? There you go. There's a picture of a taco. They've thought of everything, right? So like, pretty much don't have to use English anymore. You can just use emojis. But there you go. All right. And you know what? One other helpful tip is if you're ever in a playground and you see the emoji you want to use listed on the page, you can copy paste it because technically that emoji is text. And I think that's pretty fascinating. All right, let's move on to the next page. You guys good?
Yeah.
Yeah.
Good. The other aspect of working with a switch statement is you can also add basically a default case to your switch statement. Well, you can see that below, but they're given an example here of like quality. And the case for quality is bad, poor, acceptable, good, or great, right? And let's say we let the quality equal good, all right, whatever. However, if we don't necessarily have everything covered, right? So like here we only have 2 of the 5 scenarios covered, but we can cover all the rest with a default statement. So that's kind of a thing too that's very common in switch statement, meaning if the cases that we're selecting don't stick, then we have a fallback, kind of like an else in an else if or an if statement, right? Same type of approach. And so right now, notice that because we set quality to good, that case isn't covered here. It's not covered here. So that will go to the default. And so the output therefore is, okay, I'll take it. Like you have a choice. Right. It says change the value of quality to test when the default case is used. And I think that, we've probably already kind of got our heads wrapped around this, but if I say bad, then it says that really won't do. And if I say poor, then it should say that's not good enough, right? But if I say dot acceptable, that's okay, I'll take it, right? And if I do great, of course, that should also say the same, right? Okay, I'll take it. It's great, I had a conversation the other day with some people, and we were talking about a musical performance of somebody, and we all commented it, it was okay. Which is like if you went out for a sandwich that way and people are like, it's okay, would you eat that sandwich? I'm not sure, right? But that I think that's a pretty good example. It says the other thing they said is try adding more cases to the switch statement. So for example, they're covering bad and poor, but we could also cover the case, oh gosh, if I can just spell it, case. And what would be acceptable would be 1. That's kind of like the okay scenario. I guess that's okay. Ish. Right. And then let's cover good. So say case dot good. Learn to let the IntelliSense take over always. It doesn't mess up as much as I mess up in my typing. Right. And now the only one we're not covering is great, right? And I think they're kind of leading us to a grand point here. So I'm going to add the 5th scenario. This generate an error message is really the kind of question here. Right now, our thing is set to great. And notice, and I did this on purpose, right? And this is where they're leading us to. So we get an error message if it's not exhausted, right? Like we're not putting all the options in, but we can cover what we're not putting in with the default. But if we've got everything covered like we do now look at the error message, default will never be executed. So the structure is intelligent enough basically to look at the enum and go, you know what? You don't need the default. And you know what? We should trust that. And I think that that's really kind of interesting, right? So it works super well with enums, right? Now, if I added another case here that was called like so-so, for example, now it would be okay, right? The default, message does go away. But I think that's really kind of interesting. So I am going to comment out these couple of lines here just to keep the error message, but I think you got the point, right? So if it's not exhaustive, it tells you, and if you've already covered everything, you don't need the default, it tells you that too. I think that's really, really helpful in terms of learning how these operate. All right, so now we have this other scenario here. So it says on the previous page, you use the default to match 3 of the values in this enum, right? And then, but a default case might cause you problems if you add new cases to the enum, and the switch statement will use the default case for your new value, which may not be what you wanted. Instead, you can match several values in the same case. Now, this is kind of an interesting thought here. Kind of the same way we declared multiple cases on one line, you can also check multiple scenarios on one line. This is kind of good, right? I could see how this could be really helpful. So if it's bad, that really won't do. If it's poor, that's not good enough. But if it's acceptable, good, or great, okay, I'll take it, right? That's fine. But notice the separator here is the comma, so that's got to be there for it to work. But it's a way to declare all of those and have them catch the same scenario. Just an efficiency in coding. Now they're saying add a new case to the enum. So I'm going to call it terrible, right? So here's terrible. Now we should get an error message. What's the error message? Right, it's not exhaustive. How would we fix it?
Add another case.
Well, we could add another
And our
one.
default.
Yeah, we could put the default in, and so we could just say default. We use the colon after that, of course, and then we could just print, that's probably terrible, because it is. It's the only scenario that's gonna catch for that, right? It's probably terrible. It's almost certainly terrible in that scenario. All right, but once again, just kind of get you thinking about all the different ways to execute this. It's kind of the same thing over and over again. All right. It says, so far you learned about enums and how to use switch statements. You can also use switch statements with other values. Okay, so this is kind of interesting. For example, switch statements can work with strings and numbers. Since it's possible to have an exhaustive list of all string and number values, switch statements using these types require a default case. So in other words, you're saying, if I have a thing that processes numbers, numbers are potentially infinite. If I have something that processes strings also are potentially infinite, and what you can feed into it. So by kind of standard approach of coding, you use almost always throw in a default scenario just to be sure. When we're tying it with an enum, the enum helps to control whether or not it's necessary. But when we're using it for generic processing, so for example, instead of an if statement, that's really the scenario, right? Then you want to have that default in there. It's really a smart play, right? So here they have an animal equals cat, right? And then we look up that animal, return the string of like the sound it makes, and we're basically only processing dogs and cats. And then if we feed in some other animal, then whatever, it's not going to work quite the same. So it says, call the sound for animal function a few times, pass in known animals and unknown animals, and see how it works, and then add a few more animal cases to the switch statement and then test it. So let's try the dog, cat, and kind of generic to start for. So when I will call that function, now you can do this a number of different ways. So you can hard code it when you send it in. But on line like 20 up there, right, where it says sound for animal was preset to cat. So I'm going to kind of bypass that approach, and I'm just going to say sound for, and then inside the structure here, I'm just going to feed in a string. So I can just say cat directly.
I don't see it popping up.
You're not
there
seeing-
it is. Yep. Yeah, I must have a delay on my end.
Yeah. And yeah, it could be a little internet hiccup, but you see, like I'm typing this in here, and it really does want me to follow the format that it's expecting. And so I can feed cat, I can hard code it, right? Should experiment with dog also, just to prove that it works. And then let's put in, I don't know, lizard. What sound does a lizard make? I don't know that animal. Okay, whatever. A very interesting cultural study is, like all cultures and languages describe the sounds of cats and dogs in different ways. Right. So in English, we say meow and woof. And then I can tell you what we say in Greek for those same things. It's meow with an N and rav for a dog. Rav rav is what a dog does. Meow is what a cat does, whatever, right? And I know in Spanish it's different. Now, every language is different. I think it's really fascinating. All right. So here we put in 3 scenarios, right? And okay, that doesn't catch. But what if we add, let's add a couple of cases in here. So for example, if I type in bird, right? Maybe the sound a bird makes, I'm going to do an indent here, is return tweet, maybe, whatever it is. And then, maybe I can put in a scenario for a lizard. I don't know what sound lizards make.
I don't know.
What my
I didn't know
brain
they
says
made-
is they stick out their tongues and they slurp. So maybe I'll just return a slurp. Maybe that would be sort of appropriate. I don't know. Right. And so now you'll see that does update down here. Of course, if I feed in a new animal, right? So let's make sure the bird works. Bird. And then let's come up with even a different. Give me another animal here. How about a whale? Right. It's just basically to practice with it and adjusting it. And really what we're looking at here, we're hard coding strings. We could set those to variables. We could set them to constants and then process those. I didn't want to go through that trouble. It can seem kind of silly, right? Now they want us to go back to this restaurant scenario. So let's go take a look at what they want us to do. All right, back to the same enum. And now we're using a function to process a switch statement. So this kind of gets a little weird, but we are going to be calling basically this function to process our choice. Now look at the really, really simplified syntax here. And this is what they're kind of pulling us to, right? It says, switch statements are useful when writing functions that take enum arguments because switch statements must be exhaustive. You can be sure you're dealing with all the input possibilities. And that's really kind of the crux of why we use this stuff, enums and switches together. Right, so here's the rewrite of the stuff that we did. And then we rewrote the function much better than the earlier version, which used strings and if statements, right? And in this case, we're just looking at the properties that are already built in with that structure. And then we're using a switch instead. Beautiful, right? It's much more simple. Inside the function, the flow of the program is obvious. There's no need for any just in case code to handle unexpected inputs because we know it's exhaustive. And this is the beauty of it. If any changes are made to the enum, the program would not be allowed to run until the switch statement is updated to match. Another advantage. So this is, this seems like a pain, right? This statement, but it's an advantage to the programmer because that way, if you add options to the menu, right, you know that you have to fix the switch statement to match, right? But you have to admit, this is a much cleaner approach than what we had before, much cleaner. All right. So it says here in the structures lesson, you saw how to define properties and methods in a struct. You can also do that with enums. And this is where it gets a little fuzzy, right? Because this gives us some capabilities that the enums actually have built within them, right? that travel with the capability to do something, not just the information. So here's the example where they're taking basically the lunch choice. They're setting up the same three cases, and then they're putting in basically another property, right? And that property is a string because that's what emojis are. It runs the switch. And I want you to notice what we're feeding into it. This is weird, right? So if you've learned Python, by the way, this won't be so weird, right? Because in Python, we call this self-referring. It refers back to itself, right? So that's what's happening here. What are we checking? We're checking ourselves. So you got to think about this. When I create a version of this enum and I make a choice of pasta, burger, or soup, it knows what it is unto itself. And then it will provide the correct emoji based on what it is. I don't have to run external code to do it. It's built into the enumeration. I think this is a really fascinating feature. So if I set up a lunch choice of pasta, and then I ask, what is its emoji? It should put it in the sidebar. And I'm not seeing it. Is yours crashed also?
No, mine's working.
Yours is
Yeah,
what?
mine's working.
Okay. Here's what I'm going to try to do. I'm going to go back a page and come back. Maybe this time it will execute. Otherwise, I will. Oh, there we go. Now it's working. Okay. You go figure, right? Thanks, X. Maybe every once in a while I should reboot my machine and not just put it to sleep, right?
Yeah, maybe once in a while.
Once in a while. All right, so there's proof, right? So pasta and then the pasta icon. The self keyword is really kind of one of the takeaways here, but it refers to itself, the object that's already been created. It says you could also have a method that allows you to compare two enums. For example, in a card game like Bridge, the suits are ranked like this with the highest scoring suit on top: spades, hearts, diamonds, and clubs, right? And this enum represents the suit and tells you if one suit beats the other. So for example, here's all the cases: spades, hearts, diamonds, clubs. And then we have a variable here called rank, which is an integer. It's checking itself. And then if it's a spade, it returns 4. If it's a hearts, it returns 3. If it's a diamond, it returns 2. And if it's a clubs, it returns 1. Now, this is really kind of interesting from another standpoint too, because we're going directly to a return statement. Do you notice how they're writing it on one line? You guys caught that? Right. And this is true. We can do this as long as there's only one line of code inside the statement. When it starts to get more complicated, by the way, then you have to start throwing in your curlies and stuff. But yes, with this situation here, this would just return an integer value that would then be used in the calculation of the game. Now, with spades, right, being the highest value, clubs being the lowest, right, we have a value of 1 through 4. Then we also build into it not just a variable, which is basically another property, right? So it just takes whatever the thing is and gives it a numeric value. But now we also have a function where we're feeding in something externally. That's why we have a blank here, right? And so we're going to be comparing it to another suit, right? It's going to return a true or false. So what we're going to do is whatever our current suit is ranked at, is it greater than the other one that's being fed in? So in other words, if I fed in, spades beats clubs, is that true or false? And that's true. Or if I said clubs beats spades, that would be false, right? That would be the return of that. So let's take a look at it in action then. So here we declare one suit, spades, the other suit to be clubs. And then look at the syntax, right? One suit, which is spades. Spades beats other suit, clubs. True. All right. What about one suit beats itself? false, right? Can't beat itself. But what if I rewrote that? And so this is kind of weird, right? Because I'm surprised they didn't demonstrate this. What if you put other suit beats, what would I put in here? One suit. What should that be? False, right? Because clubs does not beat spades. Right, so you can do it in the other order too, because this is what's fascinating. When you have something that's of a certain case, and it's going to be one of these four, that's what it is. The numbers generated automatically. We kind of already saw that, the value, but the function travels with it too. So it doesn't matter which thing you start to call the function with. It can be in any order, right? But we're looking to see if the first one beats the second one. So you can switch that order around too. Then of course, if I did, for example, other suit dot beats, try that again. And then we say other suit. Does it beat itself? Of course, that's going to be false. Right? Because remember, the self rank is greater than. Right. You could also have a scenario for tie. It's the same, but you know what? That's not what we did here. Okay, it says unexpected breakpoint. I don't remember doing that, but you know what? I'm just going to delete this. And hopefully the error goes away. There we go. All right. It says add a property to the suit enum that returns an appropriate emoji for each case. All right. Well, that sounds like fun, right? And you know what? You can copy and paste these right from here, so you don't have to go looking for them. But you can also do the search like I did. So now the question is, and here's the question: is this a variable?
Yes.
Yeah, it is. It would be a variable. Yeah, would you differ on that, Jonathan? What did we do for the restaurant? And here's the question: do we do that with a switch statement? The answer is yes. Yeah, the answer is yes to that, right? We do that with a switch statement. And do we do it with a function? Okay, let's experiment, right? So here's the beauty of this is, the ability to experiment with it. I'm going to put mine up here, right? So I'm going to create a variable, and we'll call this, what do we want to call it? Emoji?
Yeah, we can do that.
Yeah, I think that's appropriate. And what is an emoji? String.
A string.
And then now that we have that, now we want to put in the switch. That really indented pretty far. All right, so there's my switch. What are we checking? Ourself or itself. And then we set up the cases. And I like the, this wants to indent, but I like the format they use below. So the case where and actually, let's do it in the same order. Spades. What are we returning? You can just come down here and grab it, by the way. You should be able to just Control-C, copy it, paste it. I like how the formatting starts out indented, and then after I finish the line, it fixes it, Like makes no sense in a way, but I'm glad it's doing it. I am not a bridge player, so I didn't know that there was a hierarchy in that game, but all right. So I'm getting this unterminated string literal, but it's fine. All right, so there's the proof and concept. Now, interestingly, just to prove that var is the right thing here, what if I switch this to let? Would this be okay? Right, you see what it's saying?
Yeah,
It
can't
says
be
let.
computed.
Yeah, it can't be a computed property because that's what this is. So we're going to control Z that. We're going to switch it back to var. So that's case proof, right? That you can't use a let here. It's got to be a var. All right. So now we are able then to take any of these. So for example, if I took one suit and I just said emoji, it should pop up the emoji in the sidebar. Pretty sweet, right? That's kind of a neat little feature. All right. So we successfully added that. Not too hard to do, right? But you see how that's really helpful. And we still have a limited number of choices. The emojis are created for us. The values are added in, and we have a function in here that determines if what we have is greater than something else. Fantastic, right? A lot of capability in that little enum. All right. Now it says, let's review this here. It says enumerations are used when you want to represent one group of related values. Each possible value is called a case. When you create an enum, you're making a new type. Instances of that type can only have values matching one of the specified cases. Makes sense, totally. Using enums can make your code easier to read and write because it's always clear what the possible values are and what they mean. You can compare enum values with the double equal sign or use a switch statement to test for all possible values. And I think we saw over and over again, the switch is really the way to go on this. Absolutely. Like if statements, switch statements are another way of making decisions in your code. They work really well with enums, but can be used to switch any type of value, right? And programmers love switch statements, by the way. Because switch statements must be exhaustive, you must handle every possible value. To handle values that haven't been specified, you can use a default case, right? Like structs, you can add computed properties and methods to enums. And it says practice what you've learned with the exercises, which is what we're about to do. So I'm going to move on to this first exercise here, and I am going to take a really quick pause in the video. All right, so we're going to work on the first of the exercises here. And on this first page, by the way, these are pretty simplistic. So it says define an enum for the compass directions north, east, south, and west. So let's do that. Let's create an enum. And what do we want to call it?
North, east, south, and west. Oh wait. Oh
yeah. What should we call the enum?
Compass.
All agree? Sure, why not? Right? Compass. I mean, we could probably call it compass directions. I mean, that would be a thing too, right?
Yeah.
So here we have the case. North, south, east, west. Not asking us to do anything with it, by the way, just making us create it. So piece of cake. Thank you. Right. How about define an enum for jigsaw puzzle pieces, corner, edge, and middle. All right. Enum. And here I would probably say puzzle pieces. And I think it's probably better to be verbose than not be verbose, generally speaking.
Okay.
So here we'll say case, corner. And I'm gonna do the longhand way this time. Edge. And middle. All right. So the next one, and this is kind of an interesting one, says define an enum for the playback modes in a music app. Okay, standard, repeat, repeat all, and shuffle, right? These are the controls I actually hate on electronic music players. I just want it to play like a regular record album, you know. Okay, so let's do that. So enum, and I'm gonna call it playback mode. Right? This is how my brain thinks about it. And we'll do a case, standard, repeat. Oh, wait a second. And they warned us about this, right? And it says you can't use repeat since it's a unique word in Swift. Repeat one is a good candidate. Okay. What's the other thing they tell us here? You should be named singulars, right? And we're failing already. So not puzzle pieces, but puzzle piece, not compass directions, but compass direction, because we're only going to pick one of them. That's kind of, and then playback mode. Right, repeat one, and then I guess repeat all. I'm going to put a space in front of it. That's not necessary, by the way, but yep. And then shuffle. But I think the big takeaway here is singular, right? Trying both ways, like with comma separated or listing them separately, and then also recognizing when you're hitting a reserve word in the language to work around it, right? The color coding there helps you. Can you imagine if we didn't have the color coding, like how hard?
Oh, God, that'd be horrible.
Yeah, that would be a nightmare. That was what the old days of programming were like, Jomar. By the way. All right. Why don't we get a start on the next one?
Okay.
And then we'll call it a wrap. Did you have a question, Jonathan?
Yeah, I was saying, speaking of the color changing there, I noticed that repeat what turned purple. So is that syntax for something in Swift?
Repeat?
So
Yeah.
when you typed in repeat, it gave up like another function for it, or like another command.
Well,
And that,
it is, yeah. I mean, I did this, right? No,
Yeah, so that went purple. Does that mean it's is that a syntax for something?
it is.
Okay.
It is syntax for something. Now the question is what, right?
Yeah.
Because it sounds like a looping statement of some sort,
Yeah.
but that's not exactly what it is. But interesting though that it's there as a keyword, no doubt. All right. Okay, so this one says this playground has a chicken type already built into it. A chicken has a breed and temper property. So it'd be dot breed and dot temper, by the way, right? And both properties are enums. Here is an array of chickens. And so I don't know if you can see that there on the sidebar, but maybe it's easier to just do this, right? So, for example, here's an array filled with them, and some are leghorns, there's Rhode Islands, there's silkies, and their temperament is friendly, grumpy, hilarious, etc. Right? And so you can kind of extrapolate what the enums sort of look like, right? So if breed is a enum, Leghorn's on the list, Rhode Island's on the list, and Silky's on the list for sure. Now, granted, I'm not seeing the entire list, right? But here's the entire list, right? So Leghorn, Rhode Island, Silky, and Plymouth Rock. Those are all the enum options. Here it's like friendly or grumpy are basically, and hilarious are the three properties there, right? And so this is why it's helpful to have these little pop-up, things here. So the chickens are all hatched, so it's safe to count them, right? So we're going to set up a variable called chicken of interest count. We'll preset it to 0. And then we're going to say for chicken and chickens, right? So this is an array of chickens that has all these enum properties built into it. If you guys are following kind of the stream of this, right? So for each chicken in the chickens array, we're going to count. So we're going to count through them, and then we should have 20, right? So and that's what we get. So then we output chicken of interest count, and we see there's a 20 here. Now it says update the code in the for in loop only to count interesting chickens like hilarious leghorns, for example. Check out the auto completion pop-up to see what the possible values for each enum are. Now this is where it gets kind of interesting, because you're gonna be invoking this, and it's gonna be kind of doing it for you, right? All right. So rather than give the answer for this, I think this is a good wind up, right? So like, here's what I would challenge you, and I have the full realization that you guys might or might not like work on this, but I would suggest, right, that you try to see if you can figure out the code to go in there for today. And then don't worry about the other exercises. We'll code through those together next time. But at least try to work on this one just to see what happens, even if it's horribly wrong, right? Just to get kind of the feel of how it's working. Next time we get together, we'll take a look at what the correct code is. But for now, we're calling it a day, and we're going to wrap for the day because I do have a meeting to go to. So